What does perfect even mean? Is there even such a thing? Ooh, can we switch up all the rules?
So, what can you expect from this talk? To know if you should stay here or if you want to go out for the lunch before we start. You still have 1 minute to choose. So what I will talk in the next 25 minutes is how AI works under the hood. It will be very basic, but it will be like, you know, when you are doing driving lesson and you just open the hood and someone explain you what are the different pieces and how they work. So this is what we'll do in this 20 minutes, because I don't know if you remember, but 10 years ago, every product manager had to learn how an API works, HTML, CSS, JS work, because you have to speak with your engineer and you need to communicate with them. And I think right now you need to know how AI works, because it's everywhere and it's a new layer, and you better understand the basic of how it works under the hood. No one is leaving the room. Thank you, sir. Don't be disappointed if I just talk about that. So who am I? I'm not original, just stole a Miyazaki style image. My name is Frédéric. I have spent 10 years working in data, machine learning, and product. Machine learning is what we used to call AI before ChatGPT, for those who don't know. And my job right now is to head of product at Scalway regarding all AI topic. I don't know if all of you know Scaleway, but we are a cloud service provider. And we have one of the largest GPU capacity in Europe and the largest in France. And so we can proudly wear these hats. I'm also a proud contributor of the media called Le Ticket, where I talk about AI-related stuff. Let's go. First, what is training, what is inference? This is really basics, but we first need to really clearly understand that before we move forward. So training, it's learning for a model, it's learning through trial and error. First, you need to learn how to walk before you walk. And you do this by falling and walking again and falling and walking again, etc. And this is exactly how our model works. They need to be trained, they need to make mistakes, and then when they are trained, they know how to walk. And this is called inference. And most of you are only using inference in your product. You are using trained model that are already working pretty fine, and they just work and they are not changed, hopefully, every day. So my first part will be about training, and the second one will be about inference. So first, training. This is the basic of how you train an LLM nowadays. First, you have to download the entire internet, which is about 10 terabytes of text data, which is a lot, but it's okay. You can hold it on a cloud provider. They will love it. Then you have to convert your text into tokens. I will deep dive into what is a token just later on. Then you have to hide some of this token, like you hide a word in a sentence, and you make the LLM try to guess what is this word. Then you try to find the token back, and you pay your expensive GPU bills. This is Jensen Huang, the CEO of NVIDIA. Give you a high. Actually, this is not exactly how you train an LLM. This is actually how you train a pre-trained model. And we also will talk about that in a few minutes. So tokens, why are you using token instead of words? It will be much simpler if we can use words. But the problem is a computer has no idea what a word is. It just understands numbers. And to use computers, you have to translate text into numbers. And so what does it look? For example, this is some raw text. There are some random words, some emoji, some accents, some ASCII characters. And when you convert that into token, first you have to split the word into several tokens. And you see for most of the time, especially in English, the word is just one token. But sometimes here, you see my name, for example, is 3 tokens. And the emoji here, also 2 tokens. And for the number, it's not just one big number or each individual number is grouped. And you see here, you have some small group of number. The same for spaces, for example, when you are programming. And so this becomes easier to understand for computer. But to be understandable, you have to turn it into numbers. So basically just a big dictionary, and you say, for example, the word many corresponds to the number 1248e. And then what the LLM sees is only numbers and numbers and numbers, and it do a lot of operation with those tokens. And so when you are paying for an API model, usually you pay by tokens, and so it's hard for you to know how many tokens you will pay, because it's words, but not exactly. The thing is, to train an LLM, the task we train it on is to predict the next token, which is really simple. You just hide a token and you try to predict the next token in a sentence. And it seems quite dumb. How can you learn so much stuff? How can you learn to talk by just predicting the next token? But the thing is it's actually quite smart, because when you are predicting, for example, this Wikipedia page, you have to learn when was Trump born, what is his job, where was he born, and what was his studies. And so just by trying to predict the next token, you learn a lot of stuff about how language works, about facts, about dates. And so we don't exactly know how, because it's just a black box at the end. But by doing this task of next token prediction, LLMs learn a lot about internet pages, basically. And so if they see a fact several times in the whole internet, they will remember it. And I mentioned earlier there are pre-trained model and fine-tuned model. And so I don't know if you're familiar with Hugging Face, but when you are on Hugging Face, you see some models that are called base and some that are called instruct. So base models are just pre-trained models. They just know how to produce fake Wikipedia pages, for example, which is quite useless, because you don't want to have just fake Wikipedia pages. What you want, in fact, is assistance. And so to build an assistant, you need an instruct model. And so you first use your base model, which is, as I say, a compression of the 10 terabytes of internet. And then you have to do another step, which is called fine-tuning. In this time, you will create conversation, like this is a question, this is the answer you should give, and you will retrain a bit your model to make sure it is able to answer like an assistant. So pre-trained model, they just generate fake web text, and they are really expensive to be trained, because it costs several million to train them, because they have to learn all the facts, all the way to speak different languages. And instruct model, they are much cheaper to train, and then but they learn to talk like an assistant. When you're done with that, you can also add extra step. For example, you can do reinforcement learning with human feedback when you ask a user what text they prefer, which is kind of useful to know how it should sound. Oh, there's an extra emoji here. Sorry about that. The thing is, why are we using GPU to do all this work? It could be so much cheaper to use just a regular CPU that are in every computer. The thing is, CPU are really great for sequential tasks. Like in this GIF, you see sequence, sequence, sequence. Every robot is doing one task at a time. Very fast, very effective. And so, for example, computer have a CPU with, I don't know, 2 to 8 cores in parallel. They can only do 8 operations in parallel, which is very low. But they do this operation really, really fast. On the other hand, GPU, as you might know, come from a graphical processing unit. And they were used at first for video games. So we have to create all the pixels at once when you play a video game. Because you have no choice. When you see an image, you want to have all the pixels at the same time. By the way, this was an experiment by NVIDIA, where they use a GPU to project some paint on the wall. And it uses a GPU under the hood. And the thing is, GPU are amazing for parallel tasks because they come from graphics. And training an LLM requires a lot of parallelism, because when you are hiding a word, and trying to fight it. It's something you can do at scale in parallel, and it works really, really well. Also, they are really fast at doing some operation called matrices multiplication that we'll see a bit after that. But it's not one GPU we use for training. It's several GPU. So this is what it looks like to go into the data center for the first time. It's a really huge rack of GPUs. And when you walk on the aisle on the data center, it goes like this. It's quite quiet. But when you go to the GPU L, each one like this, it's like, it's crazy. It's crazy noisy. It's crazy hot in there. And so it's really a different hardware. And so, yeah, GPU is an S. This is, for example, a data center we have built, which is a really huge one. It's 1,000 high-end GPU interconnected. And just for you to know, one GPU costs the price of a car. And there are 1,000 of them. So it's a really big computer. And so this is a Raptor for scale. This is just one rack. There are several of them. So it's really a huge stuff. By the way, it's a new Raptor. Regular Raptor, much smaller, but this one is dope. OK, now we're done with training. Let's go with inference. So now you have trained your model, and you say, OK, I'm done. I don't have to use a GPU anymore. The problem is you still need to use a GPU most of the time, because inference involves a lot of matmul, which is matrices multiplication, which sounds a lot complex, but it's really quite simple. It's just sums and products, and you have to do them a lot of time, really a lot of time. And so to do that, you also need GPUs. The thing is, you can use smaller GPUs, but they need to have a thing called VRAM. It's like video RAM, because you need to fit all your model, all the weight of your model, all the parameter of your model, inside the memory of the GPU, because you want it to be fast. You want your user to have a really the first token to come really fast. And you want to have a high throughput. You want to have a lot of words per minute. But I'm sure you'll say, OK, but I can manage to run a Llama 3 on my small Llama 3 on my CPU, and it works fine. So how does it work? How is it possible? So first, you can only do that with really small model, like, for example, 7B model, 7 billion model. But sometimes you can manage to use bigger model thanks to something called quantization. How does it work? It's like, I don't know if you remember the era of MP3. I'm sure you're old enough to remember that, but sometimes you can have really crappy MP3 that are really small, that have a really crappy sound, but just work. And this is why quantization is about. You just simplify, you are simplifying the signal, and in this case, it's the weight of the model. So it makes the file smaller, the model is worse, but it fits on the CPU, and it could work fine. And sometimes you just don't need a GPU. You can use it a smaller model, and you can have something that works on your laptop. And it's pretty cool if you don't want to send everything in the cloud. So I say quantization can worsen the performance of your model, but how do you measure that? The problem nowadays is that everyone is running benchmark when they release a new model. And so you see this kind of table. It's a pain, yes. I mean, who reads this table? It's awful, and the main problem is that everybody is optimizing towards these benchmarks. So when a new model is released, usually they have trained the model to perform well in this benchmark. So you just have a model that is good on benchmark, but you have no idea how it works for real users. So one thing I like, and a lot of people like actually, is to come with Vibe. Vibe are really cool. And one thing you can measure Vibe with is LM Arena. LM Arena is like a way to rank a model, one versus the other. And there is an Elo score, like in chess. So each model play against each other. And some models are doing better than others, and you see the arena is changing every day. So this is a screenshot for today. So today, the best model so far is Gemini 2.0. One thing you can notice here is that This is a license. And this is very important because, as you see, some of the models are proprietary and some are not. And the problem with the proprietary model is that when you use them, the provider can change them without telling you anything. And from one day to another, you don't have the same answer. If the provider stops working, you have nothing to do. And if they change the price, there's nothing you can do, so you are kind of locked. But with the open source model, such as DeepSeek, Gemma, you also have Llama, you also have Mistral model, you're able to change provider. If the model does work better on another provider, you can switch really quickly and really easily. And it's really cool. And the thing is, closed source model, open weight model are rejoining. So this is a performance in green of open weight model and in red on closed source model. And you see it's coming closer and closer together. So this is not an up-to-date model because there are new models in there. There are now DeepSeek. They have the new Llama 4 model is coming quite soon by Meta, and it should work great. But you see it's converging to a certain point. The question most people ask is, why do companies open source their model? And it's actually quite simple because, for example, for Meta, they have built their model anyway, and it's used in their products. So open sourcing it cost them nothing. But it helped them to attract the best talents. And this is what actually it's about right now. It's how can attract the best researcher. How can your model be the best in the world because it's well known? And if you don't open source your model, as Sam Altman say, you are on the wrong side of history. Okay, and one other thing when you try to choose an inference provider is to ask yourself, where does my data go? I've seen a lot of people today talking about US cloud provider, and the thing is, relationship between US and EU are getting weaker every day. And so, for example, there's an article, it's from a couple months ago, about how the US will continue to deal with data privacy. And Trump just closed an office that was working on that. So things are looking pretty dark from this side. And storing your data into the data center of a US company now, it means US can see anything without any protection. And this is a real problem. I mean, it depends. From some application, it's not a problem at all. But from some other stuff, it's much more complicated. Another problem is that we see from day to day new tariff happening. And so, for example, a couple of weeks ago, it was about spirits and wine, and there is a tariff war. And we've seen that in the past. US providers just shutting down their service in some part of the world. And so what would happen tomorrow if you're working with US model provider and from one day to another stop the service? It will be, bad position. And this is why, at Scaleway, we have built some alternative, and we're not the only one, but we have created this thing called Generative API. It's OpenAI compatible model. It's all open source. It serves Mistral, Llama, DeepSeek models. And it allows you to, just with a single line of code, to switch your model from your own one to a sovereign one. And so that's it. Thanks for your attention.